Hello everybody, this is Mr. Blevins. We're going to look at some homework problems from the 2.3 homework set. This is problem number 1, and it's teaching us this absolute value notation. And if, these things always say, if this happens, then this also happens. So what we're saying here is, if the absolute value of x minus, in this case it's 10, the absolute value of x minus 10 is less than delta, which is, we don't know what delta is, then that implies that a, which is 3, is less than x is less than b, which is 15. Okay, and it's important to see here that this x is the same as this x, so they're the same ones. Alright, let's get into the problem. This is absolute value inequality. So what that means is that negative delta is less than x minus 10 is less than positive delta. That's just the definition of an absolute value inequality. If the absolute value is less than some number, then that means that number is between the opposite of this number and the number itself. Okay, and then we're going to solve this thing for delta. All right, we're going to add 10. We're trying to make this look like this. So x by itself in the middle, a number on the left and right. So we add 10 to both sides. Alright, we end up with 10 minus delta is less than x is less than 10 plus delta. Alright, and then my deltas look a lot like 8s. I apologize. I don't write delta all the time. And so now this has a appearance that looks very much like what we have up here. Let me grab it and pull it down here. X is in the middle, and there's these two pieces right here on the left and right. This is to the left of the x. Well, so is this. So what does that mean? That means that 10 minus delta is equal to 3. And once again, let me fix my delta. Alright, and then the other one says that 10 plus delta is in the place of the 15. And let me give myself a little room. 10 plus delta is equal to 15. Alright, now if these things turn out to be the same, then we're great, we're golden, right? But they're not going to be, and they aren't, they often aren't when we do absolute value inequalities. Epsilon delta definitions of the limit, these types of problems. And it's like if you do the Desmos lab this week, you'll see that what we end up with when we do these types of problems are candidates for delta. Okay, so it's actually like this is delta 1 and this is delta 2. There's an upper and a lower delta. Alright, and when we break this thing apart, according to the absolute value definition, it's not two different numbers. But when we do these types of problems, we do end up getting candidates. So I'm going to call this one delta 1, and I'm going to call this one delta 2. Okay, and when we solve these two equations, I'll move the delta 1 over and I'll subtract 3, and I'll get delta 1 is equal to 7. And then when I subtract 10 over from both sides, I'll get delta 2 is equal to 5. Alright. Alright, now those are my two candidates for this delta in the problem. This is what we're trying to find, is this delta. And what this is telling me is it could be 7 or it could be 5. Those are my two choices. Well, I'm going to pick the larger of the two. I'm going to pick the 7 and show you what happens. If I pick 7 for delta, that means that this is a 7. And so I get the absolute value inequality. The absolute value of x minus 10 is less than 7. well, let me do a number between the two, like between 5 and 7. Let me do 6. And you'll see why we have to pick the other number. All right, so I'm picking 6. It's just a number that's smaller than 7, bigger than 5. So if I pick 6 here, I have the absolute value of x minus 10 is less than 6. Well, what does that translate to? Well, it becomes, to solve it, negative 6 is less than x minus 10 is less than positive 6. And if I add 10 to both sides, I get 4 is less than x is less than 16. And on the number line, that would look like this. Here's 4, and here is 16. And it's everything in between those two, and again, not including those two, but it's all the stuff in between them. So there's what the inequality is. Now, what does it have to be, according to what we said before? It has to be, if I plug in a and b, 3 and 15, that's what we have to fall between, is 3 and 15. This is what we're supposed to be in, the interval that we're supposed to fall in. All the x's are. All right. Do all our x's fall in that interval? No. This little region up here doesn't work. That doesn't fall in the region. So that means 6 doesn't work. And that means, what that means is this 7, and 7 wouldn't work either. It would be, if I did 7, then it would become negative 7, x minus 10, positive 7. If I added 3, I'd have a negative, or if I added 10, I'd have a negative, or positive 3, sorry, and a 17. It would be even worse. All right, the 3 would be okay, but this 17 would not be okay. So that's the reason why it has to be the smaller of the two, just like we talked about on that lab. It has to be this 5. Why does it have to be the 5? Because if I use a 5 there, what happens? This becomes 5 and 5. This becomes a 15. And this becomes a 5. Alright. And now, where do we fall? Let me erase all this stuff down here we don't need anymore. We have to be between 3 and 15. Alright. We are now back between the 15. We're lower than the 15. But now we're at the 5. So we don't have the this part, but that's okay. If you look at what it says you have to be between 3 and 15, and 5 to 15 is between 3 and 15. So that's why we pick the smaller number, because it narrows this window. Yeah, we do miss some numbers that we could be, but we have to get all the x's in there. Every single x has to fall in the interval, and this does. It didn't before because we went a little bit too far. So that's the reason why this is our interval, and that's the reason why 5 is the value for delta. That's why we picked the smaller of the two.